Hello.
Hello, how are you?
Okay. You got that bad news from Steve, huh?
Oh, yeah.
Yeah. Okay, we gotta talk to Natalie about it. We just have to be upbeat with him and wish him well.
Yeah.
Okay? Certainly, I don't know anything about lung cancer, to be honest. So I'm no source of any advice.
Yeah.
Anyway, if he's up to it, keep him involved here.
Okay. Yeah. Well, we'll see how.
I'd say encourage him to stay with us whenever he feels he's got camp. That's all.
Yeah. Okay.
Okay. Well, let's get ready.
Okay.
Tuesday tomorrow, huh?
Yeah.
Boy. When is the Democratic selection hit Illinois?
March 17th.
March 17th.
Yeah.
Okay. Okay. It's going to be amusing.
Yeah.
This is the strangest election I've ever seen. Super Tuesday tomorrow. Oh well. We'll see where things fall out.
Yeah.
Okay. You doing the presentation today?
Yeah, I might wait for a couple more people here. I don't know. I know Vinay said he can't make it. And,
okay.
Yeah.
Okay, I'm going to do some correspondence until you're ready. Bradley?
Yeah.
We're putting together a book proposal on chain diatoms. Okay? Which basically means any diatoms that are linked together one way or the other, which obviously includes basilaria.
Yeah.
Okay? I'm suggesting in the proposal that our proposed paper on basilaria behavior, or psychoanalysis, whatever you want to call it, go into this book. Okay?
Yeah.
So just giving you a heads up on that. Now, I don't know if the book proposal is going to be accepted yet, but we're putting the proposals together now.
Okay.
It's being led by Roberta Congestri. She's in Italy.
Okay.
Okay, she's a diatomist who knows quite a bit about diatoms.
Okay.
And I'm learning things about them too. Like when the diatom blooms, they're frequently the major species involved.
Oh, really?
Yeah. Okay, there are all kinds of chain diatoms that are stuck together by all kinds of different mechanisms. Basilaria is one peculiar example.
Yeah.
Okay, so with the proposals, we still haven't set up deadline dates and stuff like that. So
yeah.
But they'll be reasonable, I presume.
Yeah.
They depend mostly on Roberta's, what other things Roberta has to do, because she's going to be the lead editor. And we always let the lead editors do things so that it fits with the rest of their life. Okay. So, anyway, let's take a step on that.
Okay.
Okay.
Okay, well, welcome to the meeting. It's, oh, here's Ujjwal. Hi, Ujjwal. Okay, welcome to the meeting. If more people come in, we'll just let them in. Okay, yeah, so Vinay won't be here today. He said he won't be able to make it. Hi, Ujjwal. Today we have a couple things on the agenda. I'm going to talk about Open Data Day, which is an event, kind of go over. It's coming up on March 7th, but I just wanted to talk about like what it involves and what we might be able to contribute around it. Also, point you to some talks from the Cosine Conference, which is it's actually a computational neuroscience conference that has their talks up online, and we'll look at the page and I'll give you a link, and you can, if you're interested, you can watch those videos online. They're from the conference. Then after that, Jesse had a presentation that he gave in our Saturday morning meeting, and I don't know if he's going to be able to make it today, but I have a recording of that. We can talk a bit about that. It's on a paper that he read recently, and so that's our agenda. So anyone have any questions or comments they'd like to make before we get started?
Yeah, Bradley, I'd like to just give the COVID virus epidemic has just started in India. They've got 2 cases.
Okay.
And so we got participants from India. I just want to give the source of information that we've been using, which seems to be very reliable. I'll put it in the chat. And this is a very solid guy from UK. He's every day on YouTube, and he gives solid advice about himself and what's going on in the world with the epidemic.
He's been in India.
And he has been in India himself, so he understands the situation in India. He's worked in India. Okay?
Yeah, thank you very much for that. And I think that's probably good for people, well, I guess all other people, well, Canada, India, US, so, but it's probably good for everyone because...
Oh, no, this is definitely a pandemic at this point. And,
yeah, definitely.
all of us have to behave appropriately. This is an excellent medium. I've never heard of real virus being transmitted by internet.
Yeah. Yeah.
Okay?
Yeah.
I can even touch your nose. Doesn't hurt. Okay, go on back to the other stuff.
Yeah. So actually, I'll show the cosine videos first. So apparently, the American Physical Society, they canceled their meeting this year because of the COVID virus. They didn't want people in proximity. What happened to my eye? Okay, so I had something called a vitreous hemorrhage, and I think Dick knows about this. It was where as you age, okay, well, I'll tell you. Actually, it's a good morphogenesis story. So as you age, the back of your eye can cup as the morphology of the eye changes. And so what happens in some cases, happened in my case, is that it cupped too much and there was a blood vessel burst. And I suspect it's been happening for a while, just very small amounts. But it finally just gave way and there was a huge hemorrhage. So blood goes everywhere in your vitreous. And vitreous gel is it's a gel, so it doesn't dissipate very easily. So it sits in there. And so it's very hard to see, it's very blurry. And I had to get it diagnosed. I had to get it checked on. And then they decided to do a surgery to remove the vitreous and put a gas bubble in, which would clean it out. And then the gas bubble has receded now to a very small portion of my visual field, and the eye looks very red because they, bruised it up when they were doing the. Yeah, so I mean, it's fine. It's just it's a very kind of unusual thing, but yeah, I'm fine, and yeah, so it's
okay.
Yeah. So anyways,
Okay.
yeah.
Well, all of us have spike birth defects.
Yeah.
That's a new one to me.
Yeah.
Okay. Now you had the biggest floater I've ever heard of.
Yeah, yeah. Well, there's Jesse. Okay, so this is the site for cosine. I'm going to put the... Actually, let me share my screen. I can just share it. But I'll put the link in the chat for those of you who want to follow along on your own computer. Let me put the link in the chat here. This is a YouTube page where they have all the videos from this conference. So cosine is a sort of a theoretical neuroscience or computational neuroscience conference, and it's been going on for probably about 20 years or so, or maybe more now. And this year they've put all the talks online. So this is the YouTube page, and they have the tutorials. They have session 1, session 2, session 3. They have different talks that have been given at the conference. There's some interesting ones. There's computation of the instinctive escape decisions. That's I think it's about like animals, and when they make an escape move, what are the computations going on? Collective sensing and decision making in animal groups. This is Ian Kuzin is a expert in the field of collective animal intelligence, and he looks at a lot of flows and schools of fish and herds and other types of collective models. There's some other talks here, some that are more like machine learning based, some that are more based on like brains and neural computation, and then of course behavioral computation. So it's a very diverse conference. So yeah, check these videos out on your own time. I haven't really had a chance to dig into it, but I mean, you know, it's a lot of stuff going on here. So Jesse, you probably would be interested in this. Okay, yeah, you'll be interested in this because it's kind of like some of the other conferences we've talked about in the Saturday group. Some of the other conferences that we've kind of gone through the video talks for. So that's a good place to look at it. I don't know how easy it is to get into cosine. It's a pretty competitive conference. I think it's expanded since years ago, but it's still a pretty good time, and you can enjoy it virtually. Okay, so now I'm going to talk about Open Data Day. Oh. Am I on the internet here? Okay, I'm on the internet. I don't know why it's not loading. Okay, yeah, it probably just dropped my connection. There we go. Okay. So let's get this loaded. There we go. All right, so Open Data Day 2020, and this is kind of their background logo, so you can get like, you know, get a sense of what their logo is. Well, I'll describe what it is in a minute. So let me get this started. Okay, so this is Open Data Day 2020. This is something I took. This is their background, and I kind of modified it for our purposes here. So this is linked to something called International Open Data Day. And it started 10 years ago by the Open Knowledge Foundation. And so this is the link to the Open Knowledge Foundation. And I'll put a link to the slides in the chat so that you can get the link. okfn.org. And they sponsor these events, and they're distributed around the world. So, you know, different foundations, different organizations have Open Data Day events. This year's event is on March 7th, so it's coming up this weekend. And this is the 10th annual event, and the events are distributed across the globe, and each organization sort of takes their own little twist on it, and they contribute in their own way. So this was something that I did in 2018 and 2019. I didn't have a lot of response, but we can host it online anyways. I usually start an event on Open Data Day and keep it open for a while. The 2019 version used the GitHub repo and remote participation, a hackathon model. And then the 2018 event was asynchronous. So it was just people contributing, kind of randomly if they were responding to the event. And so this is the link to Open Data. There's an Open Data Day repo on GitHub here. And this is our Open Data Day repo. And this includes the 2019 stuff and the 2020 stuff. So I did Open Data Day first. The first time I did it was in 2018. And this was through Orthogonal Research, which is the other group that I'm involved with. And there's a blog post associated with this. And it involved something called theory building for data science. So it was a sort of like a lecture I give on this topic that I had, and I sort of open sourced the topic, the slideshow on the topic, and thinking about things, associated tools that we might need for this topic. And so I got a little bit of participation, but not very much. So it was worth it though to spend time making the blog post and kind of open sourcing everything. And there wasn't a lot of response at the time, but that's okay. It's just an opportunity to get things out there. Open Data Day 2019 was then in DevoWorm, and this was actually the launch of DevoZoo. So DevoZoo is the data repository that we have online for DevoWorm, and the Google Summer of Code people are familiar with this because I send people there to tell them, what kinds of data what kinds of data do we have that they can use in their projects. So this link here, this was a blog post on Open Data Day 2019, and it was basically announcing the opening of DevoZoo, which is the site where we have a number of different data sets organized by species and even things like artificial life models. And so that was, again, that had some participation, was pretty limited. But then that was an announcement which involved, maybe more formal commits to a repository and other types of activities. And so this was actually connected also to a small grant I wrote to Mozilla called Models for Data Recycling, which didn't get funded, but it was followed up on in another group, and we've been working on some things related to data reuse. I called it data recycling because the grant was specific to sort of secondary and tertiary use of data. So so that was another thing that we did last year, and again, it was limited participation, but again, I opened it up on Open Data Day and kept it open for a couple of months. So now Open Data Day 2020, I'm not sure exactly what to call it yet. I might do a blog post for it this week. So I don't know exactly what the title will be. But this is sort of the pitch for it. So welcome software developers, data scientists, statisticians, and quantitative biologists. And then one thing that we need a couple of things, I think, in this sort of campaign to maybe improve upon what we have in terms of data sets and things for theory and things for machine learning and things like that. So one of the things we might kind of put out there is this idea of building pseudo data sets for theory building and modeling. So pseudo data sets could include numeric data generated using distributions or energy potentials, a need to build metadata repositories, and generate resampled data for machine learning purposes. So Vinay and I were in a meeting last week with a Google Summer of Code candidate, and he was a little bit, he was asking about DevoZoo, and he was saying, we don't, I have some data, but how do I use it? How do I make the data labeled? How do I do this? And there are a lot of very specific things that we don't really have in place in DevoZoo. So we have the open data sets, and we have some metadata, but bringing that together more, I think, is a challenge. And one of the things, of course, that would help is to have different intermediate data sets or pseudo data sets that you can use to maybe train a model or inform a model in some way. And so this leads into the second point, which is DevoZoo maintenance. And so the other thing, and when I look at DevoZoo, when I put it together at the time, it was pretty, sort of, I wouldn't say it's stream of consciousness, but it was like, what do we have? It's an inventory. Let's just put it up there and see, if people, it's easier for people to get access to secondary data sets, tertiary data sets, and so forth. But again, a resource like that needs maintenance, and it needs things like, maybe new data sets or integrating data sets together in a way that's useful to people, who might need it for a project. Integrating data sets means, for example, integrating image data with like labeled data, or maybe genomic data with microscopy data. And it's a hard thing to do, and it takes a lot of resources. But maybe just at this point, just to identify the potential sort of places where we can integrate things, or reformulate the resource so that it makes a little bit more sense and it's maybe a little bit more advanced. I know one of the Google Summer of Code projects involves sort of reorganizing the OpenDevoCell resource. It might be a little bit a step too much to ask people to work on DevoZoo as well, but you can see those two things are kind of like maybe can be developed together. So DevoZoo, one of the things we might do are reorganize resources for each species or computational platform. And so, we have not only C. elegans, but we have sea squirts, we have basilaria, we have zebrafish, we have Drosophilus. We have a number of different species that are featured in DevoZoo. And then we have things like the metazoans, which you saw a couple weeks ago from Tom. We have links to the repos where you can get started in building models there. I think there's a CompuCell 3D link, which allows you to go to the place where you might start to build a model. So those resources need to be like maintained. Maybe links to new resources, sort of such as gene expression resources. There's a gene expression resource for C. elegans, for example, which I've been meaning to add. It's a it's a way to visualize gene expression in the embryo over development. It's not clear to me exactly how to map it to, like, microscopy data or real-time processes, but they have the data. They have like a Shiny app, which is a, like for the non-technical people, a Shiny app is almost like a web interface that you can use to run a program. So they have that, and the visualizations look great. It's just I don't know, if you just throw that resource at people, it might not be very easy for them to just pick up and use. So you add links to new resources, maybe figure out how to get people to use them in different ways. And so then that means that we need to provide intermediate resources. And so that could be models of the data or metadata or ontologies, which are like sort of ways to describe things going on in the process or in the data, a set of terms that you can use. And so there are all these things that can be done to ease the use of data, by, if you want to integrate, say, gene expression with microscopy data, there have to be all these resources in place for people to sort of make the most of that merger. And so there are a lot of potential things going on there. And then the last part, and this is maybe a bit of a reach for this year, but like I said, this is an ongoing project, is establishing semantic representation. So, things like attaching meanings to features, or using networks of character strings or words to, understand maybe like gene sequences or, terms that are adjacent in the literature, and then having maybe a controlled vocabulary for some of these data sets. And this is the link to what a controlled vocabulary is. But basically, it's like a common set of terms that people use, maybe in the literature, maybe like for interpreting data that are, maybe we propose terms or we have them in a dictionary where people can look them up so that they're not confused by different terms as a new learner to the area. So there are a lot of things in that area, but I think that's a little far off. I think maybe the first priority would be the DevoZoo maintenance. And so I think that would be something I'd probably propose in a blog post this week sometime. So I might let people know if they're interested. Send me an email or a message in Slack, and I'll keep you updated on that. So DevoWorm's Open Data Day. Open Data Day is March 7th, but Open Data Day in DevoWorm will last from now, March 2nd, until whenever we decide not to. I think probably all year, but we'll kick it off now, and then we'll get a blog post out maybe on March 7th that officially kicks off participation. Work will continue after March 7th based on what we decide we can do. Update the blog post, or maybe have an update blog post itself at some date in the future, and then tie it into Google Summer of Code. So especially the project where we're refactoring the OpenDevoCell web app, tie it into that in some way. So that's all I have to say about that. We have comments. Actually, let me get a link for this so I can share it in the chat. Okay, let me put that in there. So that's the link to the repository, wherever, if it ever comes up. There it is. That's the Google Doc. And then Jesse says, I'm curious about Open Data Day activities. Okay. So, again, like I said, Jesse, there will be I will make a blog post, and we can talk about it offline. If you have something, if you look through the slides, for example, and you see something that you want to mention, that I should mention in the blog post, I can highlight it. And then we can, once the blog post is out, then we can say more about it, maybe give an update next week, keep up with it so that it doesn't sort of go away. And, maybe we'll be able to get something good out of it. Yeah, I'm interested in DevoZoo reorganization. Yeah, I think that's a good place to start. Yeah, so let me see if I can find the link here. I know where it is. It's this link here. If you go to DevoWorm GitHub.io, it should be there. Okay, this is DevoZoo. Actually, if you go to there's a link up at the top of the screen, the upper left-hand corner, which is DevoZoo. If you go there, that actually gives you the main area of DevoZoo. You'll see that there's DevoZoo, DevoNotes, DevoMethods, DevoWorm U, DevoWorm ML, and OpenDevoCell. And these are like, this is like a link to the education, the educational stubs that we had from last year. DevoWorm ML is the ML course that we did last year. DevoMethods is actually a series of different methods that might need to be updated too, but I've just put some things up here as I've kind of gone through them. DevoNotes are a collection of Jupyter notebooks and community standards, and DevoZoo is the data. So the data are here. you have C. elegans, you have ascidians or sea squirts, you have Drosophila, zebrafish, mouse, spider embryo data, which are just some microscopy movies. Basilaria, we have movies there. Morphozoans, which are the artificial life platforms. Multi-cell systems, that's a series of sketches and demos. Developmental Bradenberg vehicles, that's the thing actually that we've been working on in another group, but that's on here as well. So there may be some, that needs to be updated as well. So we have a number of things in this repository, or the set of basically links to repositories. And so there are new resources that I haven't put up here, but there's also like just kind of making it more accessible to people. Maybe like annotating what's here, or building like more formal annotations and linking them in. So, I mean, that's all something, yeah, it's all something that, if we have ideas about how to make it better, that's what we're looking for. Just from a user perspective too. If you take a user perspective and you say I don't really know much about this area and I want to learn more, and I go to this website, and how easy is it for me to get to things. Maybe I want to do some sort of comparative analysis. How would I, do that? Where would I go first and second? And if it's not clear to me, how can we make that better? So it's stuff like that. And I think that would be helpful to people who might want to use these data, or just are curious about what's going on. So yeah, that's something we can talk about offline, or maybe in future weeks. So that's it. We have all right. So we've gotten the Open Data Day stuff done. Now we have Jesse gave a talk on a new paper that he found. It was by Carl Friston, and Carl Friston is a neuroscientist. He actually works in neuroimaging, and he's he has this theory that he's been working on for years, and he finally published it a couple years ago, and it's been pretty controversial, but he's been trying to tease it out over the subsequent years since he published the first version of this. And I'm going to go to Jesse. I'm going to play a video where Jesse explains it, and then we can maybe ask questions about it if we want. So are there any other questions at this point before I start the video? Any comments about what we've talked about with Open Data Day? And okay, well, let me. Okay, yeah, just about Open Data Day. Yeah, we can talk about it on Slack if you want to shoot me a message, or okay. Yeah, I mean, we can just talk about it on Slack. That's fine. Let's see. So we'll play the video now. If I can pull it up. I don't know if it's up. Okay, I think it just dropped the video off, but here it is. Okay. All right, let's start. So we have this is Jesse's presentation. It's going to ask me for my login and password for this. Let me see, I can probably do it This is me trying to bring up the presentation. It's just going to let me into this thing. Alright, so yeah, this is Jesse's presentation on the Friston free energy principle, and they did this thing with active inference.
Yeah, I would introduce it by saying what inspired this was I've heard about the free energy principle before. I actually was in a discussion group about it some months ago, maybe over a year ago, with it actually cropped up as part of excuse me. It came about as a discussion group that was associated with a quirky project / startup called Mindfire Global. I don't know if any of you have heard about it, but Mindfire Global is a startup that originally is based in, I think, Switzerland. And I forgot the name of the guy who founded it, but he's sort of a neuroscience guy who wanted to have his goal was to kind of have very biologically described, quote-unquote, human-level artificial intelligence. And originally, Mindfire was this, the idea was to bring many different scholars at different levels together and focusing on that and kind of bring them together and have this like conferences and then do things with outcomes from the conference and so on and so forth. But apparently that only happened one time. There was supposed to be a number of like quote unquote missions where people got together to look at specific aspects of how to do the goal of getting towards quote human level AI. And there were different, amounts of interest and whatnot in that from the people there. So I was applying to the second mission for that, which, as far as I can tell, never actually happened because startups and plans like that sometimes don't work out. But in the process of all of that, one of the discussions was Carl Friston's free energy principle and active inference. So it's a bit of that's how I came into it. And there were a number of different people trying to figure out how to talk about it. It's an interesting concept, and it's a challenging one because it is a principle at best. It is not something that can be proven or disproven, and I believe Carl Friston basically has stated this very openly. So it's kind of a hey, I have an idea that's pretty somewhat logical about how biological systems organize themselves, and here's how I think it works, and then I'm looking at my developments for this specific discussion. The discussion originated from a paper that had a very interesting title. The title was either natural selection from natural gradient or natural gradient by natural selection. Natural selection finds natural gradients. And so in the most broad sense, is the slides available yet?
It's still loading. Oh, here we go. It's finally coming up, I think. This is taking a long time. Okay. There we go. And now it just brings me to this thing, but I think I can get it.
Oh,
well, I can get it from here. Yeah, they're right here. Yeah.
I'm going to build on the main point of the paper. Yeah. So that's kind of the basic title. If we look at the next next slide is basically what the paper looks like. It's a fairly new paper on the archive, and I don't think it's, I wish I could say basically frequent at this point. Like, I think it's fairly new. The next slide was going to be my original overview for the paper. And I think I might do that. However, what I'm learning is, I think any discussion about the four principles seems to have quite a bit of, like, you can't, if you kind of have some context for it, you can basically say, hey, energy principle, an active reference has to do with how a biological system organizes itself and kind of shifts between different states, or states of beliefs, or states of action, or whatnot. And you can say that, and that's like, okay, that's great. But to have a more thorough discussion, there's a lot that goes into it. And I'm realizing that as I tried to make this original presentation for this specific paper, and you can look at the presentation overview on the next slide, this is what I was thinking of. Like, when I first went to the paper, I'm like, all right, this would be a good thing to talk about. But in doing so, I'm not presented, so to say. I'm first in before. And I've been looking at different ways that he speaks about his own work, and other people comment about it too. I feel like, for myself in particular, I would like to have, like, if I gave the presentation as I originally intended to, I feel like if I was watching the presentation, I would rather, and this is how I am, but I admit, I would have more focus on the fundamental ideas of what the fair energy principle is, and then ultimately look at what it's trying to do with the paper. And I can say what that is in a very limited and kind of basic sense now, but what that really is just, I feel like this paper and a number of the papers I've seen about active beliefs and fair energy principle tend to go back to what I was saying about how the principle is a principle and not something to be proven or not. So it's more a bunch of different, there are many different takes on, hey, here's a principle in theory, well, not in theory, but in principle, I suppose. Here's a concept, and does it really fit with this phenomenon that I'm trying to observe? And if so, how much? And one of the discussions that came up with I don't know, colleagues or friends or whatever you would like to say about it is, there's a particular limit to, similar to, maybe you could draw an analogy to David because of that, when you're making it goes to how much do you want to draw a comparison with somebody else. As in, oh, I believe beavers demonstrate emotions. It's like, well, is that emotion? Is that something you can really? Is that more matching to a concept of what an emotion is versus demonstrated behavior, or can you get how empirical can you really get about that? So I think that's the general theme for talking about a lot of in a more practical sense, what people's about the energy principles might come down to. And looking at this paper specifically, and the next slide in the discussion, I basically identified the main form of the paper as, I would suggest that biological agents approximate natural gradients descent on free energy per state estimation. So basically he's saying, this paper I think is a slightly more involved and direct assertion that natural gradients is much in line with how macro selection has shaped transitions between states or belief states or state estimation. And what does that really mean? I don't quite know how to say that other than, hey, he's saying matching brilliant descent fits really well in your fluidity principle. And there's quite a bit that could be said along those lines, but I don't feel comfortable going much further at this time. You can see in the outline in the next, even let's start to go to the next couple slides, but like you can see, I've started breaking down what is the free energy principle itself, what is active inference, and gradient descent, and then trying to flesh that out in the paper as he's getting to those things as they apply to gradient descent. Let's see if there's anything particularly interesting to say about. One thing in our paper, I think that's the slide I'm looking at too. The free energy principle is interesting in a broad sense about homeostasis and allostasis, and sort of the process of thermoregulation. We talked about that. I mentioned the medium and the message in that section because the active component of active inference kind of has to do with what I would consider, I don't know if progressive is the right word, but it sort of has to do with what we talked about today, embodied cognition in the paper. And active kind of has to do with a traditional form of cognition, or how the brain operates is sort of a passive receptive organ, just it's constantly it just receives information from the senses and calculates, and then the brain, and that is intelligence. The intelligence and cognition is the calculation of passive inputs from the sensory environment. That's sort of the classic, somewhat detached, very heady view of cognition and such. And it's obviously a bit simplistic. And embodied cognition is sort of a step towards the inherently emerging, inherently complex nature of an agent and how it is engaging with the world. So active inference kind of, if we skip ahead to a couple slides before I talk about active inference, there's the diagram. So active inference, in very simple terms, is, we kind of see, if you look at the green and then going on top to sensory states and internal states, that's sort of the, if you will, in my own words, that's sort of a passive receptive part of it. Going in, and an active inference is how there's an output that affects external states outside of the agent, the input. And I feel like I have some interesting, and I don't know, but I kind of want to say at this point, I have some ideas that I'm very interested to explore how match with what Kristen says. I don't quite know what Kristen says about this yet, but if you know, Roger, or anybody else, I would open this for a question if I was sort of just a participant in this conversation too. I'd say, I don't know where about, this would be like putting my clothes on here basically, but I'm very curious how Kristen would address the sort of the difference between an expectation, like if you have an expectation or a bias in the perspective, like you're, like a very simple example would be, you hear a noise, and you think, okay, what is the noise? You know, is it a twig breaking? I'm in jungle. Is that twig, just a harmless sound, or is that twig a lion or a tiger that's approaching a herd? And there's what I'm getting is, if you have a bias towards believing that phenomenon is deadly, a threat, and you have a reaction, that's sort of a premeditated expectation you have about the situation. And if that's your default reaction, there's an inherent, it activates your nervous system responses to react a certain way. And so what I'm curious about is, does Kirsten see that as a development of active inference, as in getting to a state where, okay, to make all of our processing faster, we have very specific biases and expectations? Or does he see that as, I guess, how fixed does he see those expectations being? And what benefits are those things? So I'll leave it at that.
Yeah, I mean, I don't know what he thinks necessarily, but I mean, from this diagram, you can see that the internal state is, there's no real differentiation between an internal state that's, say, constructed from sensory states and an internal state that's sort of innate. So, in terms of like fear conditioning, you learn maybe one thing that's very threatening from a sensory state, and there's a response to that, and that guides your active state. And sometimes that can be associated with things that aren't really deadly, but it's already sort of there, and the new sensory information can't really override that. Whereas opposed to some other internal states where the sensory states sort of allow you to infer something and build something that you can make actionable. Like if you only get partial information about a pattern, for example, you can sort of infer what the rest of the pattern is and then have an actionable state, but that might actually be wrong because you're using your inference to guide you instead of a full sampling of sensory space. So there are a lot of vagaries in this internal state. I think it's important to realize that when people say it's an internal state, it could be a lot of, they're very complex versions of that. And so sensory states will play a role, will contribute to that, but there are different ways that the nervous system can sample that information and then put it into an active state. So, I mean, yeah. And then in terms of finding an optimal state, you might find an optimal state maybe for that context. But it might not be globally optimal. Like if I think that rustling in the bushes is a snake, I'll always run away. It'll just be an automatic impulse. But there might actually be some, maybe it's not a snake, maybe it's something good in the bushes. But we don't. That's the problem with sort of internal states. Sometimes the override are. They may be good for one context, but not good globally. So.
Yeah, and I guess I'm curious to learn more if Kirsten gets to a place where he can more specifically identify, when I think internal states, I know conceptually what that is for me in a semi-cognitive sense.
Yeah.
But in reality, I don't think there's a part of your brain that's just hey, here's a set of internal states to choose from. It's not quite as, I don't think there's obviously empirical inabilities, or I guess it might be harder to do that. And I think that's going back to my original point about many of the things I've seen about person work in the sense of, okay, here's a situation, how is it applied to the principle or not?
Yeah.
And, that's okay, but I feel like, in short, it's kind of a riddle and an enigma and a five-wire, and it's useful in a very particular conceptual sense, and it is interesting, and I'm curious about it, but it's also sort of is it sort of a similar black box issue, because we don't really know how Datasetts or
Yeah.
or buoy. So anyway,
Yeah.
I think I'll probably leave it at that because we're going over time. I appreciate you attending to listen to what I say. Thank you.
Okay, so yeah, we talked about gradient descent, but that's getting into another can of worms. And then your main point is that biological agents approximate natural gradient descent on free energy for state estimation. So we were kind of talking about that where you have to, then your internal state is sort of going down this gradient descent, and the internal state can maybe be locally optimal, probably optimal, but probably locally optimal in many cases. But that's something that we don't really know. Like it's unfounded because the theory is kind of the principle's out there, but like we don't know how it really works. And so I think this is like the rest of Jesse's slides, but I think that's a good summary. Okay, so that's his talk. I don't know. Let's see. We've got some questions in the chat. Dick said, "Great." Ujjwal said, "Me." Oh, this is the who wants to work on. Oh, this is for the unraveling the behavioral psychology of bacillary cells and gliding chains. So this is the putting the talk aside here. This is something that we talked about at the beginning of the meeting. So this is a paper. The second bacillaria paper that we mentioned in the things to do for 2020 list. So if people want to work on that, let us know. Ujjwal said he wants to work on it, and then Dick says, let's see, there are a couple of questions here. Oh, Jesse said, seems to be some reverb, but maybe that's just my distorted voice that was recorded. I think there's a little reverb on the recording, but Dick said, I postdoc with Conrad Waddington. Yeah, Waddington actually proposed something called an epigenetic landscape. And it's a lot of people propose it sort of in a way that's when they draw the epigenetic landscape, they draw it as something that approximates like a gradient descent model. But of course, it isn't. It's actually a little bit different than that. But it has like people talk about like they talk about canalization, which is like where development occurs on channels along that surface. So like you have cell division points, you have differentiation points, but those things can happen in any path along this epigenetic landscape. And so he does. I think there are people have developed computational models of epigenetic landscapes that are similar to gradient descent, but I don't know if they are. I don't know if people have made that explicit connection between the two models. So I mean, that's out there. There's a literature on that. And Dick also says the best test model for free energy principle may be bacterial chemotaxis. So yeah, I think Friston is thinking about things like that, where he's thinking about, he's thinking about in terms of the human brain, but the human brain is so complex that it's hard to get a fix on the cognitive states or the behavioral states. Thinking about like, very simple behavioral systems like, bacteria or even C. elegans, we might be able to pull apart a little bit more of that principle by using a simpler nervous system. So that's very, very good point. Any other questions? Comments? So I just want to say to Jesse too, I'm still digesting the presentation. We might talk more about gradient descent. We might talk more about the free energy principle in later meetings. So why don't we keep that in mind? I think this probably deserves maybe a deeper dive into certain areas of the paper, like just gradient descent or just some aspect of like how we model things internally. So, okay, Dick. Well, thank you for meeting this week. Yeah. So thank you for meeting this week. We're at the top of the hour. have a good week. And this next week, we don't really have anything on the schedule, but I'll let you know by email. Thank you. Have a good week.